Hello, hello, hello. This is Will. Welcome to episode 14 of From Bronze to GM in miniKanren. Sorry, which episode I said? 15. Episode 15, yeah. Whatever. It's been a while. It's been 2 months since I made my last video in this series. Been busy and had some travel. Went on a few trips and was seeing family and friends and lots of work and all that. Oh, and as before, the news has there's been a lot of news. Let's just say that. So I took today's it's a little after midnight, Thursday early morning, but really I was preparing for this on Wednesday, so I took an out of touch Wednesday. I haven't looked at a newspaper today. That's not to say I haven't seen some news, but I didn't go out of my way to see anything in particular, other than watch some late night comedy, Sundups or The Onion. Anyway, I think that helped my mental state as did preparing to make this video. Actually, I think this is important to me to make these. So to help prepare, because it's been so long, I sort of forgot how to make one of these. And in particular, it's like, well, where was I? I don't remember. So I rewatched episodes 13 and 14. That was like 3 hours worth. I just watched it regular speed to get back into the spirit. And then I watched some of Vibe's Beta GM, Zerg, of course, from 2021, Gold 2 to Gold 1. That's the one I'm going through right now, just to get back in that StarCraft-inspired spirit of things. So one of my friends was asking me yesterday, well, why is this stuff important? Why is miniKanren important? Or why is, what's the point of this stuff? And I gave a few answers, but I can tell you just personally, in terms of making these videos and writing books, trying to write books, giving talks, talking with people, working on miniKanren stuff, hacking on stuff. I've been playing around with miniKanren quite a bit in the last few days and having fun with that. There's an element of, let's see if I can pronounce it correctly, Ikigai. I don't know if I put the accent correctly, but it's a Japanese term which has been translated as being something like the reason for jumping out of bed in the morning. I think I've talked about this idea at least a little bit, but certainly with all the things going on in the world and all the things going on in each and every one of our individual lives, it's easy to ask yourself, if you're studying something esoteric, what's the point of that? How why is this important? And for me, part of it is I just like making things, and and I also just aesthetically like minimal things like scheme. I like computational ideas that are elegant. There's a puzzle aspect. Certainly there's a puzzle aspect to miniKanren and relational programming that I really like. In fact, that's my favorite puzzle game of all time is miniKanren. It's like one of my friends is like, "Oh, you should play The Witness," but Jonathan Blow's The Witness. So I was playing. I was like, I get really bored, to be honest. So I was like, okay, I make up my own puzzle games. I can make up a puzzle game in miniKanren. Like I always make up my own puzzle games. I don't like playing other people's puzzle games generally. I'll take anything and make it a puzzle game. So, you know. That's just kind of the way I think about it. But I like creating things. I saw a little clip of a conversation with Danny McBride, and he was being asked, which hobbies do you have? And he's like, I'm terrible with hobbies. I'm not good with hobbies. I guess my hobby is I like creating things. Ever since as a kid, making movies, like home movies and stuff. So, yeah, I understand that, and I was talking about this on Will Radio. I was watching, or I don't know if I was watching or reading with something with Jordan Peele about writing a screenplay. I think I was watching an interview with him, and he said, his perspective was, I should forget about whether or not this screenplay will be made into a movie. I should just write it and use that as practice for writing. And I should write the movie that I want to see that doesn't exist in the world. and also he said that the writing should be more fun than watching TV. So I thought I thought both parts of that, or all three parts of that, were great. And the writing should be more fun than watching TV. I especially liked when I'm really creating things. I actually have trouble watching a movie or TV show or something because I want to think about what I'm making. So. Yeah, I think this is an important concept. I've already said that I think the hardest part of research isn't the technical aspects of research. I think it's much more psychological, mental, emotional. And I think something like Ikigai is a big part of it for me, especially if you're going to work on something a long time. Like I've been working on miniKanren now, 20 years, more than 20 years now. The book came out, the first edition of The Reason Schemer came out in 2005, but we'd been working on that book for 18 months when it came out. So yeah, more than 20 years. So it's not always going to be good times, and also people are going to ask you, well, why is this worth working on for 20 years? Especially if it looks weird what you're working on, or it doesn't look immediately practical, or if the ideas seem outside of the mainstream or maybe hard for people to grasp, or maybe people just don't understand what you're trying to do at all, which is understandable. It's completely understandable that if you're doing something really strange and trying to chip away at this problem, that someone who's not a specialist in the area is going to have trouble understanding. And even people who are specialists in areas, maybe especially the people who are specialists in that area, are going to be like, well, what are you doing? Why are you working on this thing? But for me, a big part of it is like, I just enjoy it. I'm happier in general when I'm making things. I was actually thinking about today, I've been kind of uptight and anxious with, I think to a big part because all the news and all the things going on these days, for a while now. And today was really the first day where, for big chunks of the day, I just like felt relaxed. It's like just the mental space and trying to make something, and it's like, okay, I'm gonna gonna start making this again. I want to start thinking about it again. And I've been working on miniKanren recently, and take another stab at books. Working on the books. I've been more successful with making videos than getting books out the door, but I want to try again. Yeah, so that's an important thing, and I think it's just like an important part of the psychological aspect of doing research in something very abstract. It's got to please you at some level. You've got to, for me, I remember there was a comment, I think it was on a thread on Hacker News or Reddit or something. It was someone posted one of my talks, and there was a comment about it, and someone's response was, "Bird is obsessed with relational programming," or whatever. Right? And I was like, well, I take that as a compliment. It was like, it is true. I'm obsessed with it. I try to be obsessed with it in sort of a lightweight way. I don't know how to explain it. Like, there are times where I'm trying to get something to work, and I've been working on it for like 3 days straight, and I'm staying up really late and trying to pull an all-nighter to get something working. And I have to be careful with that. Because if I get too tired, then I get disappointed, or it's easy to like, oh yeah, this is the greatest thing ever. And then you wake up the next day, it's like, wait, why did I think this was so great? Right. That also just comes with, doing research that you're really into. So right now I'm just, just enjoying it, I guess. Playing around with set constraints, and have other things in miniKanren trying to look at and think about, and it's been stimulating and fun. So it's part of my Ikigai, and I guess like 2 nights ago. I guess I don't know how to say it. Last night, which is really 2 nights ago now. I ended up kind of working kind of late, but then I got up early and went to the coffee shop to, think about some miniKanren stuff before my regular work began. And I guess that's an example where, I want to get up, want to wake up early, and kind of get at it, instead of having an attitude of, when's my first call? How much sleep can I get? It's a different attitude, and that's important to me. And I think everything else goes better also, right? So like if I'm really fired up about the stuff I'm working on, then the other things work better, I find. So anyway, I think that's important. Not just if you're a researcher, but just in general. I think that's one of the things that is precious for people, that Ikigai feeling. Okay, what else? We have a scheme workshop coming up and a miniKanren workshop coming up. Let's see here. Yeah. So here's miniKanren. Actually, I'm sorry. Let's go to scheme. Yeah. Here we go. I had these links ready. Here's the Ikigai article on Wikipedia. Here we have Scheme 2025 workshop, co-located with both ICFP and Splash in Singapore. And we got the dates here. And, look. Look who's on the organizing committee. And got a great program committee, great organizing committee. So that should be fun. And if you if you have a paper to submit or anything else, here's the call for papers. You can read up about that if you're interested. Also have miniKanren workshop. Oh, look, who's on the organizing committee? I'm doing triple duty, actually, because I was on the program committee for ICFP, so triple duty. We also have a great organizing committee and program committee. So anyway, we got a call for papers for that as well. So, if you're interested, then please look at the call for papers and the deadlines and all that. And if not this year, maybe sometime in the future. Okay, if you're interested in participating in that, and you can also, of course, look at older scheme workshops and miniKanren workshops. These are good sources for papers and talks and all that. Another thing I wanted to mention was I'd had trouble finding this technical report. Con should not evaluate its arguments. So for whatever reason, sorry, electronic version no electronic version currently available for this classic paper. But someone pointed out, and I'm trying to remember who found this. It may have been Jason Heeman pointing me towards this, but there is still a paper, or a link to this, which I'll put in links for this video, to a scan of the paper. It's not the greatest scan, to be honest, but there is a paper on scan of it online. I was just going through it, and then I saw that. It's like you had one job. Oh well. But for the most part, the scan, I think, is readable. Yeah. So that was nice. However, I couldn't find that PDF, a scan for the Ferns paper. Yeah. So it's a little bit of a bummer. So, gotten some nice comments and emails from various people in the last 2 months. One comment I got from someone was that they were hoping that I could, focus on some macro in my videos, because I'm starting to get into details of scheme. So I'll try to have at least some macro every epi. But in particular, they were saying that it's easy for them to lose the big picture when they're focusing on the micro or the technical details, and I totally understand that. It's very easy to kind of lose the thread of I feel this in most talks that I watch. I'm about halfway through, and I'm like, okay, why are we talking about this particular technical issue again? Like, how does that relate to the overall point of the paper, of the talk? And I'm not even sure if I understand what the overall point of the talk is. So I think that context is important, and so I'll try to give context as I go along, but also talk about macro things. And so macro things for this series include things like having a research notebook. And this person mentioned that even things like choosing the research notebook, like which sort of notebook do you get, it's easy to get lost in those details. And certainly I know all about that because I've tried a bazillion different techniques and notebooks and notebook systems. I will say that my personal experience after doing this for decades is that for my notebooks, for my research idea notebooks and just organizational notebooks, I've tried doing things that I've tried having like really fancy notebooks and nice notebooks and really nice paper and fountain pens with beautiful ink and all these sorts of things, and various electronics, notebooks, and fancy organizational systems. One problem with having notebooks that are too fancy that I've had is that I don't want to I don't want to mess them up or ruin them. That there's this I feel like the notebook's kind of precious and it has to have one topic. So I have all of these nice notebooks where the first 5 pages I started on something, and then the rest of the notebook is just empty. And sometimes I'll flip the notebook over to get twice the usage. So I get 2 topics in there. However, what I've actually found is that a large pad of graph paper, like I could do a legal pad, or I could just do like a white lined pad of paper. But I like the graph paper. I like the quad ruled, graph paper with like 4 squares per inch or whatever the equivalent is in metric. That I like quite a bit. Just a nice, in English, in US units, it'd be like 8.5 by 11 inch, or I guess the equivalent would be like an A4 pad of paper. That's graph paper with lines that are not too dark. I like those. I don't know why. I've always liked graph paper. They're nice for drawing figures. There's something about them I always associated with engineering and ideas and drawing and those sorts of things. So I just find it sort of instantly puts me in a more creative mode. That's what I actually like. And as far as pens, I've got some really fancy fountain pens and inks and all that. Sort of a go-to pen, actually, they're not so fancy. I like the Pilot G2 gel pens, and you can get those 0.5 millimeter, 0.7 millimeter, and 1.0 millimeter in terms of like the ball size. I think one flows really nicely, 1.0 millimeter. But the line's super thick, and the ink really goes down very heavy, and I find you have to be careful, or you'll get ink everywhere. 0.5 millimeter I find is just too fine. It's just kind of scratchy. So I like the 0.7 millimeter. In fact, I've even bought. You can buy like a colored assortment. It comes with a bunch of different colors. So I've done that before, but usually just like black or blue. G2 gel pen. There are other gel pens that I've tried. I like the G2s in general, although sometimes they get a little scratchy. And then the other type of pen I use is a fountain pen. It's a Platinum Century 3776 that has refillable cartridges that are platinum carbon black ink. That's why I like that pen in particular, is that I can carry these cartridges and then just replace them. Otherwise, I've got other fountain pens that take ink from the bottle, but I don't find that very convenient, when traveling and refilling those pens can be, with that ink in particular, can be a little messy. So I tend to like the cartridges. That platinum pen writes nicely, though I do have an extra fine nib on it. These are Japanese fountain pens that I normally use. if you're writing kanji, it helps to have a really fine nib. I've always liked fountain pens, so and so on not super nice paper, not fountain pen grade paper, with that extra fine nib, it can get a little scratchy. But I like that ink, the platinum carbon black ink, because it's highly water resistant, and it also is very light fast. And it's like I've got some notebooks where I have really beautiful inks that and at one point I realized, like, if I drop this notebook in a puddle, it's gone. And so some of my notebooks, even recently, just from washing my hands, didn't completely dry off on my hands, and I picked up a notebook, and then next time I looked down, and the cover is all smeared. It's like, uh-oh. So I better not bring that out in the rain. So anyway, the non fancy beautiful ink that I like is that carbon black ink. So that's what I tend to use, is just those big graph paper pads, and either a G2 gel pen or the platinum fountain pen with the platinum carbon black ink. Yeah. So that's what I tend to use, and I go through those notebooks. I mean, I fill up the whole notebook, and I'll have a whole bunch of different topics, and I've got, I don't know, I've probably filled up 100 of those notebooks at least. I've got all sorts. I've got every type of notebook you can possibly imagine that I've taken notes on. I've got big stacks of notebooks, and sometimes I'll go through them. I'll go through them again. But for me, it's more organizational, getting ideas down. It is kind of funny and a little, I don't know if it's disturbing or what, whatever. Like I'll be working in my notebook, and I'll be thinking, it's like, oh, I've got this great idea. This is so great. I should write this down so I don't forget. And then I'll flip back a few pages and I'll see that I wrote down the same thing. Like, a week before or something. It's like, oh, okay. There may be a reason it's in my head. But I do have a whole bunch of these notebooks that I've worked on in, say, the last 4 years, and I will go through those occasionally. Just kind of flip through them. So that's what I do, and I just carry one of those big pads of graph paper with me. That's the thing I like the most. It's big enough that I have space where I can, kind of fill up a page and have a lot on it. The really small notebooks that are ultra portable, they can be okay for me for just writing down a couple notes. But if I actually want to do work, I like having a bigger notebook. And I like the fact that these pads of graph paper, while they are, more expensive than they used to be, for sure, they still are much cheaper than like a really fancy notebook, in terms of how much I can write in them. And, the paper is not super nice or super expensive, but it's durable enough. I still have these notebooks from a long time ago, and they've held up okay. I tend to use Cambridge brand notebooks for whatever reason. I guess those were available in lots of grocery stores or whatever. They're definitely more expensive than they used to be, but that's what I tend to have. But having said that, just in my room here, I probably have a dozen types of notebooks. I've got a bunch of really fancy Japanese notebooks and paper for fountain pens and all that. But, sort of the workhorse for me, just in terms of thinking, those Cambridge graph pads. Okay. Well, anyway, that was my aside on notebooks. All right. Different people find different things work, but I actually like having a pen and paper and like going to a coffee shop and not having my laptop, and minimizing my use of the internet, and just sitting down and thinking and writing ideas for a while. I think that's like increasingly hard to get. And now I wear an analog watch. It's purely mechanical, doesn't have any transistors in it. I've got a calculator that's like an actual RPN Hewlett Packard 28S calculator. I guess at this point I actually value the things that are not on a computer. After spending all these years learning about computers and waiting for computers to get better, at this point it's like, okay, there's so much distraction or anything else with the computers that actually getting away from being networked all the time, getting away from a screen, not staring at a screen. Is that Onion article, study shows Americans now spend 90% of their waking time staring at glowing rectangles, right? That's not even a joke at this point. So, a pad of paper and a pen, and a wristwatch, a real honest to goodness calculator. Those are my little pleasures in life at this point. So, okay. Well, I'll try to keep the macro stuff in mind. And so, just context reminder: where are we headed with the scheme that I'm trying to show you? Well, we want to be able to write a metacircular scheme interpreter. That is, we're going to write an interpreter for scheme in scheme. We're going to interpret scheme programs, and the interpreter or evaluator itself will be written in scheme. Okay, so that is sort of this key computational artifact that we can play with in a bunch of different ways, and we will explore it not just in scheme, but we'll explore what we can do with that artifact in constraint logic programming or relational programming with miniKanren. But also, this is kind of the gateway drug into programming languages. You have this tiny little program that can interpret a Turing complete programming language, and you can change that artifact in a bunch of interesting ways to get different behavior and extend it in different ways. But there's this like kind of core essence of it. And so much of programming languages and computation can be studied through this one little artifact. That's really the key thing I want to get to, is this interpreter and then playing with it. And then when we get to the miniKanren stuff, we'll revisit it. Okay. So that is kind of a high level sort of milestone or goalpost. Like, we're trying to get to the point where we can write this scheme interpreter in scheme, which means we need to know and understand scheme sort of at two levels. For two reasons, I should say. One reason we need to understand scheme is so that we can write the interpreter. And the other reason we need to understand scheme is so that we can understand, well, what is this language we're interpreting? We have to understand, to write the interpreter, we have to understand how scheme works if we're going to write an interpreter for scheme. So we have to understand scheme at a pretty deep level. And that's one reason I keep going back to things like the scheme reports or other references for scheme and drilling into the details of how scheme works. And also a reminder from a previous epi, what do we need to know to get to be playing with this metacircular scheme interpreter and writing it? We need to know about lambda and procedures, Booleans and truth values, conditionals, if and cond, type predicates, pair, question mark, or pair ha, null ha, list ha, number ha, a few other miscellaneous built-in procedures like plus, times, 0 question mark, 0, recursion, recursive procedures, environments, variable binding and shadowing, pattern matching, and the evaluation rules for scheme, which we've talked about some. Okay, so that those are important things. And so just thinking, high level at the macro level, if you get lost in any of these details, first of all, just keep in mind why we're doing this. We want to be able to get to the point where we can define scheme in scheme and then start playing with this computational artifact. Okay, so that's a very big motivation, because this allows us to explore ideas like call by name, call by need, call by value, lexical scope, dynamic scope, continuations, all these sorts of things in a nice way. And then, of course, we'll get into the relational programming. And when we have this artifact or artifacts written in a relational style, we'll see all sorts of interesting behavior. And that'll be fun to play with. And in fact, that's still a major motivation for me. Is, in fact, I would say that is the main motivation for me, or at least maybe it's not like the big picture motivation for me, but this is what I spend a lot of time thinking about, including this week, is, how do we make the scheme interpreter written as a relation in miniKanren, how do we do a better job of that? Okay, so we can write that interpreter in miniKanren, but there are a lot of issues, or a lot of problems that come up. And so I'm very interested in trying to explore different trade-offs and different approaches to see if we can do better, or at least do differently. Okay. Last time we talked a little bit about conditionals, conditional expressions. We talked about if expressions. Remember, we have if expressions in Scheme as opposed to if statements like in Java. We have one-armed ifs and two-armed ifs in Scheme. Remember that an if expression is syntax in Scheme. Okay, this is a special form, has special evaluation rules as opposed to a procedure application or procedure call. So we played around with that. Yeah. So let's just take a minute as a quick refresher. So if I just type if, we'll see we get exception, invalid syntax if. Okay, so that tells you right away that if is syntax. Compare that to plus. Okay, so plus is a variable that in the initial environment of Shea scheme and our 6RS scheme is bound to a procedure that knows how to add numbers. Okay, and then we can call plus, we can call that procedure like this. So those parentheses mean procedure application or procedure call. And we can write things like this. So I can create a list that contains the procedures bound to the plus and minus variables. And so here I have a list of length 2 of 2 procedures. The first procedure, is a procedure that adds numbers. The second procedure is a procedure that does subtraction instead of addition. And I can take the car of that list, okay, and then not surprisingly, I get back the procedure that knows how to do addition. Okay. My bad typing is if I figured I'd use an external keyboard and I'd make it easier, but with the microphone placed where it is, it's hard for me to see the keyboard very well. Anyway, so here we have a sort of this compound expression, and this shows you how the rules for procedure application work. Okay, so we're going to go outside in this outer pair of parentheses. Okay, when you see those parentheses, think procedure application, unless we have the situation where the first thing after the open parenthesis is a keyword like lambda or let or letrec or if or cond. But here, in this case, the first thing after the left paren is not a keyword. It is itself another expression that has, it's a parenthesized expression. Okay. So we know that this overall expression is an application. Okay. When I say application, procedure application, just application. All right. So we have an application. The rule in Scheme is that when you have an application, all of the arguments, all of the sub-expressions, I should say, all of the expressions within the application get evaluated in some unspecified order. Now in Racket, they get evaluated left to right. And so in Racket, this sub-expression would get evaluated first, and then this sub-expression, and then this sub-expression, and this sub-expression would move left to right. But in Scheme, that's not required. In Scheme, they could be evaluated in any order. So it could go, instead of left to right, could go right to left. Or it could, 5 could be evaluated, and then this expression could be evaluated, and then 7, and then 6. It's up to the implementation to pick that ordering. Okay, so left to right is a valid ordering for within Scheme, but some other scheme implementations that might say go right to left, while that would be legal in Scheme, that wouldn't be consistent with Racket semantics. Okay, so that's important to understand. So these sub-expressions get evaluated. Now, I can make this a little more interesting. Okay, I can make a sub-expression that's basically going to be an argument to plus eventually. I can make something that's compound, right? So, if a Scheme implementation decided to evaluate this sub-expression first, well, it would follow recursively the same rules as before. So, okay, here are parens. Parens mean, those parentheses mean procedure application unless there's a keyword immediately after the left parenthesis, so open parenthesis. However, we don't have a keyword. Okay, so we have this asterisk thing. It's not let or letrec or lambda or one of the keywords. So instead, this expression is an application. Okay, so maybe the sub-expressions are evaluated right to left. 4 evaluates to 4. It's a self-evaluating literal. Numbers are numeric constants self-evaluating. 3 evaluates to 3. Asterisk, that is a variable that is bound in the initial environment to a procedure that can perform multiplication. So evaluating this asterisk or star, that evaluates the procedure, and then this procedure is called with the arguments 3 and 4, and the result of that procedure call or procedure application is 12. Okay, so that's the result is that's this expression evaluates to 12. Of course, this expression 6 evaluates to 6. This expression 7 evaluates to 7. this expression here is also an application. It's an application because we have parentheses, which mean application, unless the first thing after the left parenthesis is a keyword. It is not a keyword. Car, once again, just like with star and plus and minus, is a variable that is bound in the initial environment. In this case, car is bound to a procedure that can take, the car of a pair. Okay, now, so car is not a keyword. This application has two expressions inside of it. And we have two sub-expressions. We have car, and then we have this compound expression, which is itself an application because we have the parens, which means application unless we have a keyword. List is not a keyword. Once again, list is a variable that happens to be bound in the initial environment to a procedure that creates lists. Okay, and plus is a variable bound in the initial environment to a procedure that does addition, so forth with minus. So we could go left to right for this evaluation of this application. Car evaluates, that's the evaluation of car, which is a variable bound in the initial environment. Well, that will give us a procedure bound to car. Evaluate this application. We follow the rules recursively. Okay, so let's go right to left. Minus, well, that's a variable bound in the initial environment to a procedure that does subtraction. Plus, that's the variable bound in the initial environment to a procedure that can do addition. And list is a variable bound in the initial environment to a procedure that creates lists. Okay, and so this called list creates a list containing two procedures, as we've already seen up here. Of course, the car of that list, the resulting list, gives us that the procedure that knows how to do addition, and then that procedure that can do addition is called with the arguments 12, 6, and 7. And that gives us 25. Okay, so those are the steps in this example. Now, this example doesn't have any special forms, special evaluation rules, because everything's just an application. We don't have an if or a lambda or a cond or, a let or a letrec or any of those sorts of things. Well, let's introduce an if. Okay, so if is a special form, has special evaluation rules. We see the parentheses. Normally we would say parentheses mean application. However, if is a keyword. So we see a keyword immediately after the left parenthesis. That means that we have a special form. And so we have to use the evaluation rules for that special form. The evaluation rules for if, or that in this case, which is a two-armed if, well, in any case, you're always going to first evaluate the test expression. So here's the test expression that gets evaluated. Okay, so that expression is evaluated, and we just follow the normal rules recursively. Okay, so what type of expression is that? That is an application. Why is it an application? Because the parentheses on the outside, and then immediately following the parentheses, you have something that's not a keyword. Okay, 0 question mark is not a keyword, so this is an application, right? Let's go left to right with the evaluation. Let's say 0 question mark, that is a procedure bound in the initial environment to, that is a variable bound in the initial environment to a procedure that's a predicate that takes a single argument and returns to hash t or hash f, depending on whether or not the value passed in is 0. And then the second argument, second sub-expression in that application parens, so think application, unless the first thing appearing after the left parens is a keyword, but is not. Okay, so we've already seen how subtraction works. So we just do that normal thing. And so we get -1, 0 question mark, and -1 is false. So according to the evaluation rules of if, we evaluate the consequent expression. Okay, what type of expression is this? It's an application. You see parentheses, you do not have a keyword that immediately follows the left parenthesis. Okay, so we don't have a keyword. Now, if we wanted to, of course, we could change it up. Okay. So in this case, all right, well, the consequent is a special form. And we have parens, so normally you'd think application, however, we have a keyword immediately inside. Yeah. So we're allowed to nest ifs, those sorts of things, okay? So hopefully this is becoming comfortable for you if you didn't already know these rules. However, you will need to know these rules, okay? So this is where I'm saying I feel kind of like vibe, like a broken record. This is part of your micro, is to practice this, is to take an expression like this or make up, first of all, you should be able to make up examples like this, okay? And you should type them into the REPL, and you should be able to write them down in your notebook. All those sorts of things. You should be able to write down without a fancy editor. You should be able to just write it down on a piece of paper with a pen or a pencil and write something syntactically correct. You should also be able to do it with an editor. You should be able to check that your parens are matched and all that, including on a piece of paper, including on a blackboard, whatever, a whiteboard. By the way, that's something I definitely recommend if you do not have a lot of experience writing this sort of code, like in Scheme or whatever. If you are communicating with other people that are familiar with it, and you're in a conference room or something like that, if there's a blackboard, or if you're in a classroom or something like that, if there's a blackboard or a whiteboard, people might ask you to write the code on the board or to show them what you're thinking, or on a piece of paper at a coffee shop, or just open up a plain text editor that doesn't have any of the fancy features and just start writing code. So I think it's definitely worth your time to make sure you can do this kind of in your sleep, right? I mean, that's the main thing, is you want to be able to do this under any circumstance, even if you're tired and hungry and all that, a little irritated. It's like day 9 talking about his friend who had practiced StarCraft with one shoe on, one shoe off, his chair at the wrong height, using a different mouse or keyboard with the monitor set to the wrong height, so that in a tournament situation, when one thing is wrong or one thing is off, this person wouldn't get flustered. So it's the same thing here. Okay, you should be comfortable making up examples. You should be comfortable doing what I just said, that process of immediately identifying for different expressions. What sort of expression is it? Is it a special form? Is it an application? Okay, so what about quote cat? What sort of expression is that? Well, that's a special form because this is quote, right? Quote, and this is equivalent, of course. Is equivalent to this, right? And we know that that the evaluation rule for quote of datum is datum, so quote of cat evaluates the cat, which is a symbol, right? Here we have an expression. Here we have a special form. Sorry, this is an application. Of course, this is an expression, but it's an application. Special form, application, okay, numeric constant, variable reference, those sorts of things. You just get used to that vocabulary. What about if? If is a keyword, but if I just write if by itself, that's invalid syntax. It has to be used as part of this overall expression. So I can write that, and I can write the one-arm form. Okay, those are both legal, but I can't just write if, and I also can't write that or that or that. Those are all invalid syntax. Okay. Now, important that you're comfortable with this. Okay. Like I said, that was a sort of a standard test for beginning schemers, is that they should be able to take some complicated expression, explain the evaluation rules, and also should be able to explain each type of expression or sub-expression. Okay. All right. So that's if. If is a conditional. What I promised to do this time was to look at another conditional, which is cond. And cond is short for conditional. Right. And this is due to John McCarthy. Old school Lisp cond. And I showed you that in the page, was it the bottom of page 13, Lisp 1.5 manual, in that Lisp and Lisp interpreter, you could see that cond was there. Okay, so let's write a cond expression. So the syntax of cond is different than the syntax of if. They're actually, just like the two versions of if, there's the two-armed if and the one-armed if. They're different versions of cond, what are called cond clauses. And so, there are actually quite a few variants of cond clauses. Some aren't used very often, but it's worth at least knowing what they all are and practicing them, because sometimes you'll see these in code or a paper. Now, if you look at the official, if you look at the scheme report, if you look at R5 or whatever, you'll see syntax that looks like, you'll see the formatting looks something like this. Okay, so that is a simple cond. Actually, I've got a very happy accident there. Let's start off with something a little easier to explain. Okay, so here is a cond expression. And it's formatted in a way that I don't like. I always put the clauses on a separate line than the cond, but you'll see people writing it this way as well. Okay. So how does this work? Well, cond has one or more clauses. Okay, so it has to have at least one clause, I believe. Yeah. Okay. I didn't think there was some extension in Shay. So you have to have at least one clause. Okay, so here we have a cond clause, and this clause is a pretty standard type of clause, has what you might call the test part, and like the consequent part. Now let's look at R5 to see what these what the actual terminology is. Okay. Con clause test and tail sequence, they call it. Okay. So test, this is the test, and this is the tail sequence. Now it's called the tail sequence partly because we can do more than one thing here. If I wanted to, I could do something like display some output. So in this one clause, we have the test, and then if the test evaluates to true, a true value, I should say, then the following, expressions or statements are evaluated, and then the value of the last expression, that's what is returned as the value of the entire clause and the value of the cond. So here you can see there's this one clause, and sure enough, 0 question mark or 0 of 0 is going to return a true value, which is hash t. And because the test is true, the test succeeded for this clause, the, what's it called? The tail sequence is evaluated in order. Now, anything other than this last expression is going to be evaluated for effect. So I'm going to display the string hello, so you can see that gets printed out in the new line. And then, in addition to this output, the value of the expression times 3, 4, the value which is 12, is going to be the value of the entire clause, which is the value of the entire cond. And so sure enough, you have a 12 there. Okay, so that's simple syntax. Now, let me get rid of the rest and just have a simple value that goes with that test for that one clause. Now, that wouldn't be that interesting, except that we can have more than one clause. All right. Now, in this case, this new clause, we're not even getting a chance to evaluate the test because the evaluation rule for cond is that the clauses are tried in order. So we start with the first clause and then evaluate the test expression for that first clause in this case. And if that test expression evaluates to true, then we evaluate the rest of those expressions, and the value of that last expression is the value of the overall clause and the value of the entire cond. However, if the first test evaluates to false, then the next cond clause is evaluated and its test gets tried. Okay, so let's try this. Okay, sure enough, we got to the even test, which gave us that test is gave us back a true value, so the plus 5, 6 gets evaluated. Now, another thing we can have is a clause with that's an else clause. So there's a special keyword else. So this is an auxiliary keyword that can only be used inside of cond. You can't just write else outside of cond. That doesn't mean anything. Say misplaced aux keyword else. Okay, so it's misplaced because it's not being used with inside of the cond. Now you can define a variable called else, that's fine. But if you want to use else as a keyword, that goes with con, it has to occur within the con. Now this else effectively is like writing hash t here. This is a test that's always true if you want to think of it that way. And in fact, in other Lisps, you would, some Lisps where t is true, or basically a true value, in some older Lisps you might write like a t here, that type of thing. So, you could write a hash t, which is going to evaluate to itself. That's going to be considered a true value. But there's also this keyword, auxiliary keyword else that goes with con. Now, the else has to be in the test position of the last con clause. That's the only place it can occur. We can't. Oops. All right. Oh, come on. There we go. Okay, so that's no good. And similarly, this is no good. Okay, so we can't just have the else as we can't have the else in the test position of another clause. Now, hash t we absolutely can. We can put hash t as the test in any position, any clause we want. That's not a problem. But for else, which is this auxiliary syntax or auxiliary keyword, that has to be in the test position of the last clause. Okay. So this is like a fairly simple and fairly traditional con clause that we're looking at right now. We can have many more clauses. We could have 1,000 clauses if we wanted to, and we could also just have an else clause. That's perfectly legal, but there has to be at least one con clause. Okay. Now we already saw that we can have more than one right-hand side, or I shouldn't call it the right-hand side. We have more than one expression or statement that comes after the 0 question mark. So in this tail thing, right? Just like we saw before, that's perfectly fine. So we can already see that there are a few different types of clauses, right? So we have the clauses where we have an else, we have a clause where we have a test, and then the expression whose value is to be returned, and then we have something where we have multiple expressions or to be evaluated for effect that occur here. And so I have to be careful because I did say statement. I have to look syntactically to see exactly what this is. Let's just see what it says. Tail expression. Okay, so there's a tail. What does it say? Con clause tail sequence. What is a tail sequence? A tail sequence is, I see, 0 or more expressions. That star means 0 or more, followed by what's a tail expression. Okay, so expressions appearing in tail context is what that means. So so we have 0 or more expressions followed by a tail expression. Okay. So that's what's called a tail sequence. All right. So these are called expressions. And then the last one is a tail expression. We'll talk about tail context and all that later. So let me show you another variant of a con clause. All right, so a con clause can just have a test expression. And in fact, because anything other than hash f, any value other than hash f is considered true, we could have a single test expression that evaluates to something like, in this case, 30. And since 30 is considered a true value, then the value 30 is returned. So the idea here is that we can have the test also act as the value to be returned if the test expression returns a non-hash f value. So it's like, well, all right, if this test evaluates to something that's not hash f, go ahead and return its value. Now, of course, in this case, the test evaluates the hash f. So therefore, so hash f doesn't, it's not true, and so its value is not returned. Instead, that test is considered to have failed, basically, and we move on to evaluating the next clause and its test. Okay, so anyway, so now we have 4 different types of con clauses, and I'll show you one more. All right, let me hold on a second here. I want to think of a good example of this. Okay. I don't know if this is a good example, but it's an example. Oh, okay. I had it backwards. This is one I don't use very often. All right, here's what we want to do. Okay. All right, so there's this arrow notation. So here you have a test expression like before, and here car of the list of 5, 6 will evaluate to 5. And since 5 is not hash f, it's considered a true value, the test, passes or succeeds or whatever the test expression, that test passed, and that value 5 of the test expression, what the arrow means is that value 5 gets passed to a procedure that's, specified to the right of the 5. So here we have a lambda expression. This is like defining the square function. So lambda x times xx. So this is a procedure that lambda expression will evaluate to a procedure that takes one argument and then attempts to multiply it by itself. Okay, so the 5 will be passed in to this procedure, and it'll be squared, and we'll get back 25. We could, let's see. Or how do I make it odd? Instead of writing a lambda expression, we could just pass in the procedure to, or sorry, pass in that value 5 to an existing procedure like odd question mark. So let's try this. Oops. Okay, and we get hash f because 5 is not even. How about we pass it into list? And now we have list 5. Okay. So now we have 1, 2, 3, 4, 5 different types of con clauses. So you can see that con clauses, cond has a variety of different types of expressions, but they all have this idea of a test expression. Else is basically the always true test. And then if that test evaluates to a true value, any value other than hash f, then that clause is going to return a value. And it could be just the value of the test expression itself, like in this case, or in the other versions, it's going to be the last expression on the right, or with the special arrow syntax, the value of the test expression gets passed to a procedure. And then the value of that procedure call is the value of the clause and the cond. Now, there is something that we actually encountered in the very beginning. We'll go ahead and let's set this up again. So I want to make all these clauses fail, or at least get down to the else. So here, the car of list hash f, that will evaluate to hash f. Okay. Null is list cat null. No, it's not. Is 0, 0? No. How about 8? Is 3 even? No. So this should bring us down to the else. Sure, we got a 42. Now, let's just get rid of this else clause. Okay. All right. So now we have 4 clauses, and the tests for all 4 clauses will fail. What's the value of the cond expression? If you were paying attention at the very beginning, you already know, or if you think about it in terms of if, one-armed if, you should know. Well, look at that. It doesn't appear that there's any value at all. But let's use our trick. Oscar Waddell showed me this ages ago. Let's just stick it in a list, the value of that cond expression. And sure enough, there's our friend void. Remember void? We can create a void object. But void object is not printed by the ShayScheme printer in the REPL if it's just the void object by itself. If it's list void, that gets printed. You'll see list void. But void itself is suppressed, sort of like how the dots and the cons pairs get suppressed in a proper list and that kind of thing. So here we have an unspecified value. In ShayScheme, we have void. So the value of the cond expression, if none of the clauses have a test that evaluates to a true value, the value of the entire cond is the unspecified value, which in Shay is void. Okay, so this is why it's generally good practice to have that last clause with an else, so that you don't fall off of the cond, you don't fall through all of the cases, and then have a value that of the entire cond being void or the unspecified value. Because remember, void is actually a true value. Okay, the unspecified right, is not hash f, so it's considered true. Let's just try that. Yep, there you go. So the unspecified value, which is, in Shea scheme is void, we can create it by calling void with no arguments. That's considered true, and therefore we get back 3 instead of 4. So this can cause a lot of trouble. Believe me, there's a lot of pain here if you accidentally write your con like this and evaluate. You think your cases are complete, and they're not, and you have a con that's returning the unspecified value, and that value is getting passed around and treated as a true value. That can really mess up your logic and be very hard to track down. So as a defensive programming measure, it's generally good practice to have an else. And if you really don't think you'll ever, if you should ever reach that case, then you could do something like in Shea scheme, you could call error. Whoops. You can make this message nicer, but the point is you could program defensively, have an else, so that if you ever reach that last con clause, this error will get signaled. So, or you could throw an exception or whatever is the right thing for you to do. Or maybe there's a safe value, or maybe you return -f or something, depending on how the logic works. But if you really think you should never reach that, you probably should have an error. Okay, well, that is cond, and you can read all about it in the Shea scheme programming language, and also in the various scheme reports. So let's see here. So ladder practice. Well, the micro is to play with cond. Get used to coming up with examples. Get used to writing syntactically valid code. And get used to, writing syntactically valid expressions like the con with all the different clauses. Get used to writing them on a piece of paper, on an editor, with or without paren matching, with or without syntax highlighting. Writing it on a whiteboard, writing it on the blackboard, all those sorts of things, just so that you can do that. Because this is one thing I've noticed, is that a lot of people, when they're using con, they'll have trouble with the parentheses or whatever it is. Let me just show you one thing which I think we've seen before. So in certainly in R6, and I think in R7, you're allowed to have these square brackets, okay, as long as they're matched. The squares have to match, the rounds have to match, but you're allowed to write these square brackets. And for some people, for things like cond, they prefer the square brackets to limit the clauses. Okay, so as long as you match the squares and the rounds, that's fine. And I like this. I think this is pretty nice, just because it really makes it stand out what the clause is and what the tests are. Now, after you've played around with cond enough, and same with pattern matching, for the most part, it's not really a problem. However, it's nice to be able to have different types of the limiters. So that's also something that you could practice. Certainly, you should be able to read this sort of thing. Notice where the squares go. Normally the squares are for the clauses. Now there's nothing about, you could, if you wanted to, you could go the other way. Okay, so you could do that. That works. Let me just change this so we don't get an error. So that works. You can put the squares there, but that's considered very bizarre. That's pretty disgusting style. Only do that if you really want to annoy a schemer. Okay. So much of Scheme is pattern matching, like visual pattern matching. So if you do that, you will definitely annoy people reading your code. But this sort of bracket style is fine. Okay. Whoops. I put that under macro. That should be under micro. Well, for macro, well, let me put something here for macro. Well, okay, so one more micro. I don't know if to put this macro or micro. Okay, so read up on cond in the usual places. And then, here's saying, think about why you are interested. Why are you interested in programming languages and computation or Scheme, functional programming, Lisp, miniKanren, relational programming, whatever it is? Presumably there's a reason you're watching these videos, right? So if you're watching these, and certainly if you're doing your ladder homework and all that, that's a major investment, and hopefully you find this stimulating, enjoyable. There's something you want out of it. There's something you want to learn, or there's some skills you want, or you want to be part of something, part of a community, or you want to make something, whatever it is. Maybe it's just a joy of learning. Maybe you have something you want to build. Maybe there's a paper you want to read, or you want to write a paper. Whatever it is, what is it? Why is that important to you? Okay. And that can be just for you. You don't have to share that with anyone else, but, might be worth thinking about. And, I think it's good, it's like, and it doesn't have to be a pragmatic reason. It doesn't have to be, maybe it helps you get a job or whatever. Or maybe it helps you get on a project you care about, or make make some software you care about, fine. But it could just be because you like, programming and you want to learn more about it. Or it could be you like the puzzle aspects, or there's something elegant about the design of these languages, or you find the implementation interesting, or you find the connections to logic interesting. Whatever it is, okay? Maybe you want to create something and share it with people. But that's, I think, worth thinking about. Why do you find it interesting? Is there a certain feeling? Like for me, there's a certain feeling that I get. It's kind of like the Artosis nerd chills feeling. It's a little bit like that, but there's a feeling of satisfaction. There's a feeling of elegance, and like these little tiny interpreters. It's like I've seen them, I've written them so many times, but they're still so full of wonder and possibility. I don't think anyone's gotten anywhere close to exhausting what you get with a little lambda calculus evaluator. I think we're still just scratching the surface of all the things you can learn about it and play around with it. And if we ever do exhaust part of it, you just put the interpreter in a different context, like a relational context, and then it's almost like you have to start over again. So for me, that's deeply fascinating and satisfying to play around with. So anyway, that's some macro and a chance to put something in your research notebook. If you don't have a research notebook, that's part of your macro. If you don't have a pen you like or a paper you like, the only thing I would say is the important part of the research notebook is that you use it, you write in it. Okay, so if you like a fancy notebook and a fancy pen and fancy ink, that's fine. But like I said in the beginning, I would just caution you that you don't make everything so fancy and so precious that you don't actually use it, because you don't want to mark up this beautiful thing. I once was making, and I still have the materials for it, this notebook for 5,000 years with special paper and special ink, right? You could bury it in the desert in Egypt, and 5,000 years later, all the secrets of miniKanren will be revealed. And I was telling a friend about this. Oh, that's so great. Let me see. And then they look at my notebook and they're like, yeah, this isn't worth keeping for 5,000 years. Touche. But it's like, it doesn't have to be, right? This is like a working thing. So yeah, I would, an artist friend of mine who has this book, Nothing Precious, right? It's like, well, these aren't precious things. These are, the notebook is to help you get unstuck, to help you organize, help you brainstorm. So you don't want to make it so precious that you don't work in it. But find a notebook that works for you, find pens that work for you, find a place to work on it, or a time, or an attitude, or just, when I'm really feeling creative, I could work anywhere. It doesn't really matter. If I'm not feeling it, if I'm not feeling the sense of, Ikigai, then it doesn't matter where I am. I kind of have to jumpstart that some. And for me, sort of protecting and nurturing this sense means, I have to take it seriously that I spend some of my time and energy on things that are important to me. Today, I went through a bunch of stuff in my not very organized room, and I uncovered a couple keyboards that had been sitting dormant, and I plugged them in and charged one of them that had a battery, and I was playing a little, making horrible noises, and uncovered some of my art supplies and stuff like that. And it's like, okay, this is important to me. I'm not worried about, if anyone else likes the sounds I'm making or or the drawings or paintings I'm making, it has nothing to do with it, you know. And yeah, it's important to me that I play around with miniKanren. It's important to me that I make videos. It's important to me that I try once again to write a book. Okay, that's all important. So think about it for yourself. You know, what's important to you? You know, what are the things you want to create? Like, think about the Jordan Peele. Okay, here's a good macro. You know, the Jordan Peele quotes I gave in the beginning about, you know, writing the screenplay without worrying about if the movie's ever made, writing it for practice writing the movie that you want to see that doesn't exist in the world, and also making that writing more fun than watching TV. So he actually did it. And I think that's full of wisdom in terms of creating things. So that's another piece of macro. Maybe reflect on that and how can you take some of that, you know, into working on something that maybe you aren't working on as much as you'd like, or you'd like to get unstuck on. I'm going to take that to heart for trying to write a book again. And also I took it to heart tonight and yesterday. So yesterday, you know, I wanted to rewatch these episodes so I get back in the hang of it. So I watched almost all of episode 13, but then it was getting pretty late. I was like, I think I'll try to make the video tomorrow. So tonight I watched 14 and I watched a little vibe, and it's like, all right, it's starting to get a little late. I probably won't start making the video until after midnight. But okay, that's fine. I'll make it. So, was it 2:13 now? That's fine. I really wanted to make it. So that's the Ikigai, and I'm hoping tomorrow I'll have some Ikigai feeling and want to spring out of bed and, you know, start working and start making things and thinking and playing around with ideas and all that. Okay. That's it. I hope I can make another video soon. You know, 2 months break, I think in some ways was good. But I think I'm ready now to make some more. All right. Take care. Hope to talk to you soon. Bye-bye.